Okay, so I've just started recording here. We have an unaligned point cloud data set with our CAD data here. So we have our datum A cylinder that's been extracted from the CAD, our datum C plane and our datum B plane. There. I've also aligned these, applied these GD&Ts. We don't need this D, so I'm just going to delete that. I don't think they have any effect at the moment. Let's just refresh that. Okay, now what we can do is run an initial alignment. Hopefully it will get it quite close there. This software doesn't seem to have a endpoint alignment.
Yeah, it does. It's in transform alignment.
Oh, okay, yeah, but can you click a point on the CAD and a point on the point cloud?
Yeah.
Okay, right. So failing the initial alignment, you would actually go through and run that to get a closer one, because that's all we're after, to get it close to start with. So now we've actually got our datum A cylinder here, and we can turn this on and we can see that it's actually extracted all that, but it hasn't done a very good job of the fit there because it's the best fit only to the initial alignment. So what we'll want to do now is actually just do a datum-based alignment using the cylinder and this datum C plane, which is going to resolve 5 of the 6 degrees of freedom. So we're going to go to our datum-based alignment, select our datum pairs. So the first datum pair is datum A cylinder. So remember, see there, you've got the 2 icons, the yellow extracted one behind the green nominal one, so it shows it's got both in there. So we've got our datum pair 1 and then our datum plane C. So we're going to click it in the 3D view or in the tree view. There. Yep. Now, so I think they are actually both in there, aren't they? Datum pair 2.
Oh no, they should stack up.
They should. Hang on, let me just do this again. Might have needed to do a shift select. So cylinder A and cylinder C. I just did a control select. Anyway, so that should be fine. If I click solve now, that will resolve. I was just thinking. So I've got a big data set. So that's green. That's green as well. So this fella up here is it's green as well, but that's within 0.3. So let's pull this down a bit. Cool. Can I
just double click on the numerals there next to the arrow?
1. It's actually looking pretty good. So it's about 0.2 out. Let's have a look here. So deviation 0.2. So it's not a bad result. Now that we've got that, well, it's very likely that that's not always going to finish on 0. So then we need to refine that alignment by going to our best fit alignment. Let me just refresh this first. Got a best fit alignment. Now this is where the parameters are a little bit, you've got to be a bit careful about. So the constraint we need to make sure is on, and we need to use a defined coordinate, and that coordinate is revolved around our datum A cylinder there, and we want to lock the translation in X, Y, and Z, and lock the rotation in Y and Z, and only allow rotation about X there. So this should really bring that down to almost zero. So firstly, we also want to just use this selected data only. And you can't actually select one of these features, the datum plane B that we've already got selected. You still need to select that plane on the CAD there, and that'll be a max distance value. So we can now go tick, and that will then just do that very slight rotation. And so we're within 9 microns there in Z. So that's solved that for us. So in effect, we've got a perfectly aligned point cloud.
So in terms of our,
So if you go,
yeah, cool. Hit stop on the